Welcome to the another session in Frontiers in CFD. Uh, CFD simulation for thermal management of lithium-ion battery pack in a serpentine channel with air as a working fluid. So first objective is preparation of geometry for serpentine channel lithium-ion battery pack along with the casing, generate mesh and name selection on computational domain, applying the boundary conditions and visualizing the results in the post processor. So this is a reference geometry which we are following. It is taken from one of the research paper. So welcome you all to another session on Frontiers in CFD. So today we are going to do the CFD analysis on multiple channel flow for thermal management of lithium-ion batteries. So this is one specific geometry which is there. This is considered with respect to the reference paper which is already published. So the channels will be somewhat like this, where we'll be having some inlet and outlet. So you have the multi-directional flow of fluid which is uh, will be useful for cooling the lithium ion cells. So accordingly we'll proceed for preparation of geometry. So let's start with the fluid flow fluent option. First of all, let's start with the new design modular geometry. Set the units to mm. Click on xy plane. Okay, let's click at zx. So out of which, what I will do first is I will prepare this outer casing, and later on we are going to slice the geometry with the help of the cylinders. So we are not going to prepare cylinder as of now. First we will prepare the sketch for this outer casing which we are outer the channel which we are having, and based upon that we will proceed. So if you see the channel diameter, it is our radius is 13, so diameter will be equal to 26. So let's set the unit first, that is mm. Create we say, okay, just a minute. So from this point you can take as a reference over here. So from this I will consider, let's say, from this point. So accordingly, first this is your center. It is my zx plane, so I will draw the sketch on this. So let's draw a line from the center at a distance of 19. So let's specify this as a 19 here. Then we'll draw, okay, so this distance is 19. So from this I will draw a circle of diameter 26. So dimensions, let's take this diameter will be equal to 26. So in this way we need to draw 1, 2, 3, 4 and 5. So based upon that we'll proceed. So each and every distance will be at 19. So from this also I will proceed here up to the horizontal distance, that is equal to 19. Draw one more circle over here of same radius, so that is 26. Okay, so the same we are having. So create one more time, you draw a line from this again horizontal, the dimension will be equal to 19. So let's put this, then one more time draw a circle of same diameter, that is 26. Okay, yeah. So draw one more line, let's proceed. Let's say horizontal, that is 19 here. Then draw circle of same one more time, draw a line horizontal, then let's take this is 19, and this will be your last circle. So draw one more time your circle of same radius. Now apart from this we have a kind of we can say 6 distance over here, so that we need to do. Before that we have arc by 3 points. So this is the first, this is the second, and this one. Okay, so if you just check it, the dimensions of this, I need to put this value as equal to 13. Okay, so each and every case I will go on to do the same thing for your sketch. Okay, so okay, let's do the next one. Arc by 3 points. Let's say this is the first, this is the second, and this will be your tangent. So specify this dimension as 13. So let's see. Okay. Similarly, you have to do it for the remaining. Draw arc by 3 points. First, this is the second, and this is your tangent. Specify this dimension as 13. So okay. So this is the third point we are done. Similarly, do it for the next. This one. This is this second, and this is your the third one. So put it dimension as 13. So here. Okay, so all this curve I have tried to draw. Similarly, I will do it from the bottom side also. Arc by 3 points. This is a first, this is your second, and you need a kind of tangent over here. Specify the dimensions over here as 13. So here it is 13. Same way, do it for the other. Arc by 3 points. This is the first, this is the second, and this is the third one. So make it dimension 19, make it 13 here. Okay, slightly not proper. We'll modify this, trim it. Okay, so we'll do it again. So draw arc by 3 points. This is the first. Ensure that this is on the same line, and like this. Now make it dimensions 13. So what you should check is you should have these points to be on the same line. So this is one thing you can do for check. So one more time, draw arc by 3 points. This is the first, this is the second, and draw a tangent to this. Specify this as 13. Okay, similarly, one more time, draw arc by 3 points. First, second, have a tangent to this, and let's put the dimension to 13. So okay, so we are done with this all the kind of curves. Now let's check the geometry one more time. So this is how the outer casing which we require. Now we'll prepare this portion which is around 6 over here. So total distance we already have, that is from this point. So we'll draw one more line here which is at a distance of 19 in the horizontal direction. Specify the dimension over here as 19. Then go up by a line which is equal to 3 distance in vertical. Here it should be 3. Let's put that value as equal to 3. Similarly, draw one more line which is the lower direction, vertical. So put it again with same dimension, that is equal to 3. Now let's draw this and join with the this one. Okay, simply you draw a horizontal line, not necessarily with respect to dimension. Yeah, later on we are going to team it. Same way, from this take a vertical line, have a dimension that is equal to 3 here. Similarly, have a dimension in the lower vertical direction, that is again 3. So let's put this is equal to 3. Let's draw it in here. Any horizontal line you can draw. Same way, I will draw any horizontal line here like this. So we have drawn 2 horizontal line. Later on we are going to trim out the unnecessary things which are not required. So one more thing which is there, arc by tangent. So okay, the last thing which is there is related to the arc by tangent again. So let's take this point, let's take this, and have a kind of arc over here. So let's take the dimension here for this is equal to 5. So we'll have to do it for all remaining. So carefully we need to do. So this is the first, this is the second, okay, do it one more time. arc by 3 point. This is the first, this is the second, and let's have a kind of tangent over there. Specify this dimension to be equal to 5. So carefully note. Okay, so in this way I have done it on this side. Similarly I will do it on the other side. So arc by 3 points. So this is the first, this is the second, and let's have a kind of tangent to this is like this. Yeah, so specify the dimension here, that is equal to 5. So it will be somewhere like this. So one more time, draw arc by 3 points. Let's say this is the first, this will be your second, and have a kind of tangent to this. Let's denote this dimension for this. For this is equal to, let us say, 5. Okay, so we are done with this part. This looks R33, we have 5. So I will do this again one more time. Modify, this is, I will trim this. No. Okay, I will do this again. So first one, arc by 3 points. Say this is the first, this is the second, and have a kind of tangent to this. Okay, so specify the dimensions for this is equal to 5. Okay, so likewise we have done. Now let's proceed with the trim operation. So modify, let's go with the trim operation. So whichever the things which are not required, we are going just to trim out, because we need to create a kind of channel over here. So whichever the things are not required, we'll just go on to trim it. We need to carefully trim, otherwise there are chances that you might not be in position to do the extrude operation. So carefully all the points we have to select. You must not keep any of the point to avoid the errors that can come out. Okay, just a minute. Later. So carefully select all. So first of all I am trimming all this circles. Okay, then whatever in between we have, that also you should trim. Okay, so this is the operation which is done. Let's go back to your sketch again and just visualize whether it is in the right way or not. Let's go with, so let's check with the sketching. Looks to be proper. Let's check with the extrude operation. If it is not possible, then there are chances of error. If it is easily extruded, then there is no issue. Let's make it apply. Instead of add material, make it frozen. I will put it 65 here, and let's make it generate. So it is generated in the y direction as of now. So you can see the geometry which is available here. So this is the object which is there. So this is in your z direction, so accordingly you can have. Okay, now let's create the cylinders. So create primitive, then cylinder. So just observe the location. First one is 9 mm. Set. Okay, first I will provide that the second circle of this is 20, radius diameter is 20, so radius will be equal to 10. So x will be sorry, y will be 65, this will be equal to 0. Now the location will be at a distance of 19, so this is a z direction, so let's put it minus 19 from this. So okay, just a minute. Let's put this is 0 again. Okay, so I need to shift it in the arrow. Let's z, that is 19. So here you can see, let's make it slice material and generate. So you can see one of the cylinder is generated here. Similarly, one more time we'll do the same operation. Create primitive, that is cylinder, make it slice material. Y component will be 65, this will be equal to 0. This is 10 as it is. X component, okay, I need to put it in Z component as per this. So first one is at 19 distance, so second one will be at a 38 distance. So let's make it slice one more time. So you can see this is how the geometry which is has been there. So this will be like a part of the casing here. So one more time, create a primitive, let us say cylinder, sorry, not cone, this is cylinder. So let's take a primitive, that is cylinder. Z component will be 57 now, this will be 65, this will be equal to 0, radius will be 10. Instead of add metal, make it slice metal, generate. Similarly, one more primitive cylinder, make it slice material, this is 65, this will be equal to 0. Z component will be 76 now, make it generate. So the fourth one, similarly create a primitive, that is cylinder, this will be 65, this will be equal to 0. Z 95, let's make it generate. Okay, make it slice material. No, okay, so we have generated all five. Now this geometries I need to make as a slice we have done the slice operation. So this is like a casing which has been provided. So I will just unite all these bodies. So go to the boolean operation. So I will make these bodies unite. So let's understand which are those bodies. This is the first, second, third, fourth, fifth, sixth, seventh, eighth, nine. So these are the bodies I am going to unite, make it apply, and let's generate. So in this way, this is the outer structure has been prepared. So this is which is available at inside. Now this portion will be again, we will generate some of the primitives. So it is like a outer casing for your lithium-ion cells. So let's go to the primitive again, go with the cylinder. Let's change the orientation to Y. Z component will be equal to 0. Now radius will be equal to 9. Instead of add material, one more time I will do the slice material. Z component I will put it 19. Just observe now, here I will make it generate. Okay, you can see now this is how the geometry has been prepared. Okay, so this is a lithium ion cells, out of this casing will be there. So one more time, create a primitive, that is cylinder. Z component will be now 38, this will be 65, this will be equal to 0. Here instead of add metal, make it slice metal, generate. So second we are generated. So one more time, create a primitive, that is cylinder. Instead of add metal, make it slice metal. So I will put it 57 now. So this will be 65, this will be equal to 0, make it generate. So third we are generated. So create one more time primitive, that is cylinder. Instead of add metal, make it slice metal. So Y component will be 65, this will be equal to 0. This will be 76 and make it generate. So it is the fourth one. So create, let's more primitive, that is cylinder. Instead of add material, Z component will be okay 95 here. This will be 65, this will be equal to 0. Make it slice material and generate. So we have generated the outer casing also. So this is outer casing, this is outer channel through which the fluid is collected to go. These are the casings for your lithium ion. This is the first lithium ion cell, second lithium ion, third, fourth and fifth. Now this is the first thing which is we are having is related to your flow channel. So I rename this to as channel. I will rename this to as a channel. Then this is your casing here. Now this is related to your casing. So I will put this as casing here. Then these are your cells 1, 2, 2, 3, 4 and 5. So these are all cells. Now we need some operation before proceeding, as we are dealing with multiple kind of channels, like the one which is specified here. So accordingly we'll change the geometry. So first of all I will create one more plane here. So plane I will take it from not from centroid, I will from plane I will take, not xy, I will put it zx, make it apply. Let's make it offset z. So first of all I will put it 14. So you can see now a plane is generated at a distance of 14. So accordingly I will slice the geometry, make it generate. So let's go with the slice operation here. Slice by plane 4, make it apply and let's generate. So you see it has been sliced. Similarly one more plane which is here. So you can take either from the plane which is generated right now, that is also one option. So offset, let us say by 3, put it here. So one more plane is generated. Now this is one more plane. I will do one operation which is again a slice. So let's create uh, slice. Let's select plane 5. Let's make it generate. So we have sliced the geometry. So one more time, create a primitive, not primitive, plane. So this will be again from plane 5. I will shift it by offset z to equal to 14 here. So one more time we'll generate. We'll do the slice operation. So plane 6, make it apply. Let's make it generate. So this is second. So create one more time. Say plane. So from plane 6 offset by z, that's equal to 3. Let's make it generate. Do the not thin. Do the slice operation with respect to plane 7. Make it apply. Generate. So one more time, create one more plane. From plane 7 I will shift it by 14 here. So make it generate. Do the slice operation with respect to plane, make it generate. So create one more time plane which is offset by z, that is equal to 3 and generate. Do the slice operation one more time with respect to plane 9, make it apply and generate. So we have generated 4 channels, 1, 2, 3 and 4, separated by 3 mm of gap. So accordingly now because of the slice operation, what has happened, the cells are also getting sliced. So I don't want this cells to be of slice. So what I will do is first of all, channel by channel I will go. This is the casing which we are having. Some of the unnecessary portions which we don't want, that we will delete, because as for the geometry, if you see here, so there is some space between the two channels. So go back to your, just identify the solid over here. So let's take this solid and this solid. So I will do one operation which is called as body delete here and generate. So the outer casing of the body is delete. So one more time, in the same operation I will edit and select the three bodies which is generated. So make it apply and generate. So I deleted three bodies which are in between. So now this will act like a channel 1 2 3 4. Now in between that the casing is also divided, and this we say the cells are also been divided. So what I will do first is I will do the things for your casing. So for this I need to hide the geometry 1 2 3 4. So I will hide this body. Now again so once you hide the body, let's make the body unite. Okay, I just selected the casing only. So we'll make the body unite with the help of boolean operation. So let's make it unite here. So now the cells are not united. So what I will do is I will hide the casing now. So hide the casing. Now what will left out is only cylinders. That is your lithium-ion cells. So one more time, go with the create boolean operation. Make it apply. Let's generate. So do it for all 5 cells. Okay, so we are done with all the unit operation. Now the number of bodies are reduced. So this is of okay. I will do one thing. I will show all bodies. So what we have left out is this is the channel which is there. This is the casing which is provided. Then this is the cylinder 1, cylinder 2, cylinder 3, cylinder 4 and cylinder 5. So that is your lithium-ion cell. So these are channels which we have. So total 4 channels are there. So now what I will do is I will, wherever the channels are there, so we'll already make these are the 4 channels, so we'll form this as a one part. So we'll form this as a one part so that the number of parts will be less. So let's make it channel. Okay, so this is the casing which is individually it is only one out there, so no need to do anything, but for this solids I will put name as a cell. Second also you need to cell. Third either you can specify cell 1 2 3 4 also. I just specify here cell, and the last one. Okay, so 5 total cells we are specified, so we'll make this also as a form new part. 1 2 3 4 and 5. So make it form new part. So now you see 3 part and 10 bodies. So this is the casing which has been there, then channels through which the fluid is likely to flow, and this is your the cylinders which are sorry, the cells. So let's rename this also as cell. Okay, so casing, channel, and this is your cells. So each and everything which we are done we must have united so that there will be uniformity in the geometry. So as far as the geometry is concerned, the geometry preparation is there. Now let's do one thing. These are the channels through which the fluid is likely to flow. So I will change this to fluid. Remaining the casing will be solid itself, so I am not going to change it. Cells again they are going to be solid material, so I am not going to change. Only thing which you have changed is the channels because the fluid is flowing through it. So this is the first part. Let's save the work. This we see. So I will put it name. Okay. Again put the name. So we'll put the date also. Date. Okay, save this work. If you save the work, you can access it later on. So that is one important thing. Now let's generate. Go to the mesh option here. Click on edit. Okay. So geometry preparation is over here. It is in the Z direction we have prepared. Somewhere you can prepare either in uh, some other direction also. So let's open the mesh. Now when the mesh is open, you can generate the mesh over here. So first of all, I generated the default mesh. Let's look at whether the mesh is that proper or not. If you want, you can make it slightly better. Let's say 0.0. Let's take it 0.05 first, or let's take it 0.005 first. Let's see the statistics. 21,000 only. So as of now, so let's make it generate and let's see how the mesh becomes. Okay, no changes as of now. So I need to change the size because no changes was there. So let's take it 0.002. If the changes occurs, we can follow it because earlier 21,000, it is 58,000. So I will take it 0.001. Make it generate. It will be somewhat finer than the earlier one, but again the time required will be more. So this looks to be better, and now it's time to proceed with the remaining things. So depends which is you are considering inlet and outlet. Accordingly things will change. So I will go with the name selections as of now. So select this faces first, this one, and I will select this and this. Okay, so these are my inlets. So I create name selection, put here as inlet. This will be the one more time, do the name selection. Okay, so just check there should not be conflicts in the boundary condition. This is the inlet, this is here, so these are the outlets. Okay, so there should not be any conflicts in the boundary condition. So first one, this was inlet, inlet we have specified, so it must be outlet. This is the outlet, and from this fluid is coming in because this was inside inlet, so they must be outlet. So accordingly we must check it. Now next thing is I need to give the cell boundary as a name. So what I will do is I will just hide the channels now. Hide. Okay, so apart from the cell I will hide all other bodies. So these are the cells. Now I will give the boundary conditions on the cell. Okay, so I will put it cell boundary. So third thing which I have done is cell boundary, because I need to put boundary condition in setup, so that's why we have done this. Now I will make it show all other bodies. Now one thing I will do is the casing is there, so I will put um, hide all other bodies. Now this is the casing. I will select its surface also. You can specify this name selection also here. Let's say casing boundary. So just for identification we have considered this inlet outlet. So let's show all bodies here. Inlet, we have outlet, then cell boundary, and we have the casing boundary. Okay, so let's do it. Update. So we'll see mesh translation to Fluent is successful. Once this message occur, you can close the window, and let's go with the next part that is related to your setup. So let's click on edit. So develop precision, I take it number of processors 10. Depending on your configuration you can select, but the student version and other thing that also taken into consideration. So let's put the things as per the setup. Okay, now let's proceed with the setup. That is, we need to select transient, specify gravity in minus 9.81 because this is a positive. We must specify in the negative. You can see the inlet and outlet as per what we have specified. So accordingly, it must be correct. So let's go with the model. Here I will put it energy equation on. Make it okay. Here I will put the K epsilon model. Then K epsilon model, enhance wall treatment, thermal effect and curvature correction. So make it okay here. Now next thing is energy equation is already turned on, so no need to do any other thing, but let's go with the material. First of all, which material we are using. So let's say I want to change its solids. The outer layer of the cells are actually covered with nickel, so I click on nickel over there. So make it close. The casing you may consider to be, let us say, if it is provided with the aluminum, or you can, by default it is already available aluminum, you can keep it aluminum, or you can change it to different material also. So I am keeping here aluminum as it is. I am not going to change it over here. So this is a air as a working fluid we have considered. You can select different working fluid like water or something also, it depends. So next go with the cell zone condition. I am not going to change anything. So let's go with the boundary conditions. So there are many boundary conditions available, so out of which we need to apply at the required point only. So the cell boundary which you are observing, we have specified cell boundary. There only we are going to specify the wall temperature. So first of all, cell boundary region is there. So click on edit, click on this edit, and specify your material, say nickel. Say temperature, I put it say 323 Kelvin, around 50 degrees Celsius. Close, make it apply and close. Same way for the sixth one, we'll go with this one. Cell boundary contact region, temperature, let's put it 323. Select the material, here is nickel, make it apply and then close. Make it apply here also and close. Let's go with the next part. Cell here, temperature, let's put it 323, like nickel, make it apply and close. So let's do it for all remaining two. So make it here, temperature, say 323, select the material nickel, apply, close, make it apply, close. Here here temperature 323, instead make it apply, close. Now remaining thing which we have, like casing boundary, if it is, we are specifying by default the material is aluminum, so the casing boundary will be considered as by default aluminum. So if you are selecting different material, in that case you can change it, otherwise you can keep it. So one more time I will put boundary condition here at wall cell. So let's say temperature here nickel and put it 323. So make it apply. So let us say if you have selected copper as a casing material, in that case wherever the contact region, casing boundary contact regions are there, there you need to specify the respective material. Just like we did it for nickel, you have to do it for the required material. Next thing which we are doing is inlet. So at inlet we are going to specify some velocity, let us say is equal to 0.25 meter per second, make it apply, and let's close. So 0.25 is what the flow speed of the fluid. You can specify 0.5 also, or point. Okay, let's make it somewhat bigger. Let's take it 0.5 and make it apply. So we have specified the temperature on the cell boundary, and then inlet and wall cell. So let's proceed with the next one, reference values. Tell the computer from where to start. I will say it is inlet here. Select the zone. Reference zone will be your channels through which the fluid is flowing. Then go to the initialization. I will put standard initialization, make it inlet here. Click on initialize. Once you click on initialize, this option will be available. Next thing is autosave. I'll put it to around 20. Go to the solution animation. Here in the solution animation, we'll put it the temperature as a parameter. Here I will put as a total temperature. So select all. If you want a better scale, I will put it float instead of exponential scale. So make it save display, close, close, select the contour and make it okay. So the scale could have been exponential if you are not selected the float. So we have set the animation also. Let's go with the next part. Okay, one more time, we'll just click it. I'll just see. Yeah, total temperature is there, not an issue. So let's go with this one. Number of time step, I put it fixed as it is. Time step size, you can change it. I put it to 0.5 and let's have a run on it. This. So the temperature contours will be visible once the residual starts. So the total temperature window will also be visible. So if you are observing the windows like this, okay, so you can see some the fluid flow patterns also. Say we have specified wherever we have specified the inlet, accordingly the cells are getting heated. The fluid which is been specified as inlet, the fluid is flowing. It takes some of the heat away from the cell, and accordingly you can visualize the kind of simulation over here. So we'll run this simulation for some duration of time, and then let's say up to 100 time steps. Once this is completed, we'll just check with the post processor how it shows us the things. Definitely you can put some other parameters also, like wall temperature, also total temperature. In addition to that, you can set the animation window which shows the velocity also, or some other parameters. So I just shown only one, but there can be some others also. So let's wait till the simulation completes to 100, and then we'll check what happens in the post processor. Okay, so we have done up to 100 time steps. Let's save the work. Once save the work, we can open the next part that is related to. So I will close the geometry now. Uh, let's close the Fluent also. I just run it only for 100 time steps. You can run it for more, and then also you can visualize the post processor result. But just for visualization, I will put it. Close this window, and let's open the last part, that is the result. Click on edit. Okay, so we need to visualize the temperatures. So I will put it the volume rendering on here. Instead of pressure, I will put it temperature. So you can put it global also. You can put the required temperature range which you have specified. So let us say user specified, if it is put let us say 298 to around, if I put it 333 Kelvin. So let's make it apply, and you will see some contours available. So depending on how many time steps and other thing you have done, it can take some time. Also we have put some higher resolution also, that's why it's likely to have somewhat higher value. So let's go with the legend which is on the left hand side. Let's put it some the better way. Let's put it fixed, and let's increase the number of value tricks. Aspect ratio I will change it to slightly, make it here, so it looks better now.